this assessment, we're asked to start with this benzyl chloride and do a synthesis that results in formation of this cyclopropane. We're going to work this, as we do all synthesis, by going backwards. And so we know that the way to put a cyclopropane into a molecule is to react with the so-called Simmons-Smith reagent, essentially a carbon-zinc bond on one side, making carbon a nucleophile, and a carbon iodide bond on the other side, making carbon an electrophile. And so carbines are kind of nucleophiles and electrophiles. What's this carbene forming molecule going to react with? It's going to react with an alkene. Now, a key question here, whenever we draw this alkene, we can show it as either the E or the Z alkene. It's actually going to be using the E alkene or the trans alkene. How do we know that? Well, the cyclopropanation is a stereospecific reaction, and if we look in the product, we see that with the cyclopropane drawn in the plane, one alkyl group goes back into the board, the other alkyl group on the other side comes forward. So those alkyl groups are on opposite sides of the planar cyclopropane, so they need to be on opposite sides of our alkene. So we specifically need to start with the trans alkene. How do we make trans alkenes? Well, here's where we kind of have an idea of where we're going. The way we know, one of the major important ways we know to make carbon-carbon bonds is to react an alkyne with an alkyl halide in an acetylide substitution reaction. And so we want to work backwards to the alkyne. So let's go ahead and draw the alkyne that we would want to start with. It would look like this. So here's our alkyne. Those are going to be the alkene carbons, CH2 benzene, CH2 benzene, CH2 CH3, CH2 CH3. So kind of like numbering carbons to make sure we have all of this right. Now, how do we reduce an alkyne to give a trans alkene? For that, we're going to use sodium and liquid ammonia. If we wanted the cis alkene, we might have used H2 and Lindlar, but here we have to have the trans based on what the product is. Well, this gets us back to then our last step, and let's actually number the carbons here. 1, 2, 3, 4, 5. We'll call this one up here carbon 1. And so we're going to be making a bond between carbon 2 and carbon 1. And so to do this, the molecule we're going to react it with, we're going to have an acetylide ion, where that's carbon 2, that's carbon 3, carbon 4, and carbon 5 are coming off. There would be a sodium cation probably hanging out by that acetylide ion. But this we would expect to be a nucleophile at C2 and displace the chloride at C1 in an SN2 reaction. This is how we would synthesize the cyclopropane product on the screen.